blah. I encountered the area encounter indicates the length. Da, 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 da. Okay, still going. Let's revise the code to correct the lengths of the arrays and try it again. So still going. Cool. Okay, okay, we still here. Nice, beautiful. Look at that. That is nice. I know I probably shouldn't get as excited as I am, but I'm getting excited. um, uh, Created a very beautiful chart. Let's kind of see. Ooh, nice box plot and a beautiful pie chart. Welcome here. Back to another Granularity AI tutorial. Today we are going to talk about something that I think is pretty important to me, only because there's this idea of making sure that AI can execute code, right? We can give it a task, it's able to complete that task, also execute that task, and then we can go on our merry way. So with that being said, I wanted to create a data visualization tool that is simply able to not only generate the code, but also execute that code that it generates. In the past, if you take a look at my past videos, I have one tutorial using AutoGen, where AutoGen at the time, we're not using AutoGen today, but at the time, AutoGen, when I made that video, could generate the code, but it wasn't executing. And I kind of had to copy and paste the code itself and then run the code by itself to then generate the visualization that I was trying to use. I will make sure I tag that past video to this video so that you guys can go back and check it out. But mainly we're going to be creating a data visualization engineering agent. So if that sounds interesting to you, where you want to create an agent that is not only able to generate the code, but also execute the code, please make sure you hit that like button. Please make sure you smash that subscribe button. Please make sure you comment. Feel free to dislike. If you dislike, all I ask is that you leave suggestions, you leave comments, you leave feedback. We want the constructive criticism to make sure that we provide you the best content that we can provide. Anyways, with that being said, let's jump into it. So I have a data set that I got from Kaggle here. Let me move my face out of the way. This colorectal cancer risk and survival data. Here's kind of the general CSV. We can kind of take a look at, it has age, gender, race, region, pretty explanatory stuff. Insurance. This is a pretty nice data set, not gonna lie. Chemotherapy, what does that say? Radiotherapy received. Okay, so it's a pretty nice looking data set. Even tells kind of what the stage they're at in diagnosis. Very nice data set. I do enjoy healthcare, medical, biological data sets, so this definitely scratches an itch for me. So we're also going to be using something called, I think I could find it, something called LangGraph. Here, there we go. No. There we go. Which, within LangGraph, there's a package called LangGraph Experimental. And that's kind of where you're able to find the packages for you that you can use to, again, create an agent that can generate code for you. And not only generate that code, but also execute that code using the Python REPL tool, I believe. Took me a while to kind of find, it's a very simple code actually, but it took me a while to look through the documentation and look through a bunch of other resources to kind of find it and hand it to you guys. So take this as a gift, as me doing the work for you. I will leave some of this documentation and leave some of the inspirational resources I use for this. But again, code is fairly simple. It's very easy to use. Um, I do plan in the future to do bigger projects with this Python RAPL tool from LangChain. But for right now, we're going to keep it simple. So once we have installed this LangChain experimental, LangGraph, LangChain hub, Plotly. I am using Plotly for the data visualizations, so I'll direct the agent to use Plotly and nothing else. And we might play with the prompts a little bit here too and see what it kind of comes up with. But let's give it a try. And we're also using the GPT-4o mini um, model. So you've already seen the data set. You already see what kind of model we're using. And the prompt that we're using. You are a skilled data visualization engineer. Given the data frame, generate 3 distinct and insightful visualizations that best represent the data. Use Plotly to create the visualization code, ensuring quality and effectiveness in conveying key insights. Display the resulting visualizations. So that's the prompt that we're going to use to shape how this agent performs. With that being said, again, make sure you subscribe, and here we go jumping in. So I did a pip install on a few packages. Give that some time here. Once these are kind of already installed, then go to installing the main packages here: LangChain Experimental, OS, OpenAI. We already, like I said, we are using the OpenAI models. Pandas, just in case the agent wants to use those. Plotly. The Streamlit one, I don't know why Streamlit's in here. We could take that out. And then the get pass, we have pandas twice as well. The get pass is just to protect my API key from you guys. So don't want to rack up charges with people using hundreds of dollars or thousands of dollars worth of my API key. So anyways, once we have that and we've loaded these packages in, let's go down here and set our environment variable to, boom, hit that, good. Now let's go ahead and load in our data set. Like I said, colorectal cancer prediction.csv, cool. And then let's go ahead and make sure we're able to run our model, have the agent also use this model in its calls, boom. Here we go, creating that Python agent that's going to use the Python RAPL tool here. Boom. And then now here comes the fun part. So again, very simple code, very, very easy to kind of put together. I'm sure that you could make this something massive. I don't always think that in these showcases you really have to do like a massive project. I think showing something as simple as this, where it's just simply having the agent create code and then having the agent execute that code. Personally, for me, in my perspective, that's good enough. I've used AutoGen in the past and created or written loads of code to do something just like this. Even then, I couldn't even. I guess I could get the agent to do the code or to execute the code. But this just is way simpler. I think the only thing that might make this more useful and efficient is a critique agent. I didn't include that in here. I just thought of it, but a critique agent would be helpful. But then that also could take a while. If I'm just looking for quick insights and see what this agent can generate, I'm not going to do anything extensive. But let's go ahead and run this one. So as you can see, entering new agent executor chain. Give it some time here. To create visualizations from provided data, I will utilize Plotly for effective data representation. So you can see it's taking a look at the data, blah, blah, blah. The area encounter indicates the length, Okay, still going. Let's revise the code to correct the lengths of the arrays and try it again. So still going, cool. Okay, we're still here. Nice, beautiful, look at that. That is nice. I know I probably shouldn't get as excited as I am, but I'm getting excited. created a very beautiful chart. Let's kind of see. Ooh, nice box plot and a beautiful pie chart here. Let's see here. So I want to see if I can maybe enlarge this. Maybe not. Anyways, so let's kind of go through and what we was able to create. Now, if you are familiar, also this was something. Um, Pandas AI was something I had looked into in the past, and it was pretty much like a data scientist's best friend, an exploratory data analysis assistant. This to me, way better. Imagine like uh, you're imagine that you are dealing with a data set that has 50,000, 60,000 rows. You do not want to deal with generating all these visuals, all these. I think now they have like tools that does it itself. But like let's say like you're a startup. Maybe you don't have the ability um, to spend the money on like data bricks that can do like the auto visuals, or spend the money on these enterprise tools that might be able to do like these visuals. You just want something quick and easy. This right here, quick and easy. um so let's see here. Next, I'll proceed with creating three distinct very blah 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 blah. A bar chart showcasing the distribution of survival rates among different socioeconomic statuses. That's a beautiful thing to create. Box plot visualizing the age distribution based on the stage of diagnosis, also beautiful. A pie chart illustrating the proportion of treatment access quality across the data set. Let me start with the first visualization, a bar chart. This is nice, right? Also, I kind of like how it's interactive, where it kind of is like a I don't know if it's called I guess it's kind of like tooltip-ish. If you ever use Tableau, I think this is called a tooltip, or I guess just details added into it. Survival. So it says here, blue is deceased, red is survived. For the survival status of each socioeconomic class. So high, low, middle, blah blah blah. So it seems like there is a lot of individuals, and again, this could be on the data itself. Um, Again, maybe for some it didn't have like a label for which socioeconomic status they had. Let me see. Let's see on the data here. Where is the socioeconomic? Is it here? Or maybe we could have just made this data. Oh, there it is. So a lot of lows, a lot of middles, high, high, high. I need to activate my Microsoft Excel, so I'm not able to filter anything yet. Let's see. It appears that the bar chart for survival status by social has been created, but I'm currently directly in this environment. So I see in the middle that 35.978K survived for in the middle class, with 17K deceased. 17K deceased. So this kind of bar chart might need more work, right? And you could, I guess, ask the agent, like, hey, here's the bar chart that was produced. Can you kind of do more on the socioeconomic side? But it's a good start. So let's keep going. I think this might be a nice one. Age distribution by stage at diagnosis. So stage 1, stage 3, max 80 for stage 3, median was 71, lowest fence was 69 with a minimum of 43. And then for first stage, we have minimum 34 with the max being 71 for stage 1. With the, what is this? Third quartile being 59. It appears about da 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 da. And this one, proportion of treatment access quality. So for 60% of the data set, the treatment or the access to treatment was good. So I'm gonna assume like that means majority of people could get access to treatment, maybe because of insurance, maybe because of I don't know money, whatever it may be, deductibles. I'm not an insurance guy. I have no idea how that works. Nor would I want to be an insurance guy. Let's not go down that road. Anyways, uh, and it seemed like for 35,000 individuals, the treatment access was limited. Again, could be insurance, could be socioeconomic level, who knows? Um, if you have or ever been in the healthcare space or ever worked on it, you know there could be a lot of variables keeping someone away from receiving the treatment they need, especially when it comes to insurance. A lot of fine print. And yeah, I have my gripe with insurance companies. Again, let's not go down that road. and, um, since I'm able to display the video clearly, I will summarize the insights. So the bar chart for survival status, this chart shows how different socioeconomic statuses relate to survival outcomes, giving insights into which groups may be more vulnerable or resilient in terms of survival. Interesting. Box plot. This box plot provides a visual representation of how ages vary across different stages of diagnosis, highlighting potential trends or outliers that may be present in the data regarding how different ages affect stages outcomes. Pie chart for treatment access quality. This chart illustrates the distribution of treatment access quality, allowing stakeholders to see which types of access, good or limited, are most prevalent among the patients in the dataset. Thought. The visualization have been successfully created. Blah, blah, blah. Final answer. The three distinct and insightful videos have been created. A bar chart showing survival status by study data. Blah. Okay. I personally think 2 out of the 3 out of these visualizations can be really, really valuable, especially this treatment one, as well as this distribution, age distribution by stage of diagnosis could be phenomenally huge. I think this socioeconomic one needs a bit more work. Um, but honestly, let's try it again and see what it generates. I'm curious now. If it doesn't generate anything good this time, no worries. As long as we got something good the first time, that makes me happy. But let's kind of see here for a second. I got a bit of an error. What is this? Parsing error seems like output parsing occur in order to pass this error. Blah, blah, blah. Handle parsing error true. Sometimes this handle parsing errors piece doesn't always work. Just giving you a heads up. But sometimes it does. So let's try it again real quick and see what happens. Maybe this time I might put something out. Again, it's not perfect. The prompt isn't bulletproof. You could make it bulletproof by adding different like scenarios it might run through. Um, but again, like you just have to do more prompt engineering, more fine tuning, and then see what kind of pops up out of it. But it looks like it started something here. Okay, what we got? Ah, cannot parse output. I don't know. So it looks like it's coming back with an output. I don't know. I don't like that. Let's see. Uh, it's funny that it comes back with I don't know. At least it's honest. Reframe from adding I don't know in, let's see, output response in output. Let's just do let's not specify output. Let's just do I don't know. Like the more specific sometimes you get, the more it might hurt you in the long run. Um, just throwing that out there. I've had my times where I try to be really specific. It doesn't always work out the way I want it to. So just keep that in mind. Okay, we got something. No errors. If it throws the error this time, we'll move on and that could be the tutorial. But let's see here. Get time to think for a little bit. Now, I wouldn't recommend using the O1 models for this, mainly because it's overkill when it comes to something like this. Using the 4.0 models completely okay, um, but I would not go to the extent of using something like an O1 or an O1 mini. It seems like overkill. Those are very good reasoning models, don't get me wrong, um, but it wouldn't be my take. Ah man, I got another error. Anyways, this might be something I have to look into. It seems like it came back with a lot of I don't knows. I'm not sure why. But in the beginning of the video, you could see that it was able to generate. Now, you may have to kind of play with um, the the prompt. This is a LangChain experimental tool. So usually with experimental tools, they're also not bulletproof. You will run through your errors with those. But again, if you're looking to speed run your data analysis work, your data scientist work, maybe even your development work, I would definitely use something like this. Right now, even in my own work, um, I barely write code. Like I write code sometimes, don't get me wrong. But at this point in 2025, I've already made it a point not to write code anymore. Not I shouldn't say anymore, but not to write as much code as I was in the past, not doing as much troubleshooting on my own when it comes to figuring out errors within my code. I am simply delegating a lot of my work to um, to having AI do it or certain agents do it. Like I have a coding agent, I have a prompt agent, um, I have a brainstorming agent. If you're familiar with like Jira and story creating and creating like epics and whatnot, I have a Jira agent. I don't feel like doing a lot of work anymore, so now I direct a lot of my stuff um, to AI and agents. But anyways, if you like what you saw today, if you like the content that you got today, please make sure you subscribe. Hit that subscribe button. Please make sure you dislike if you want to. All I ask is that if you do end up disliking, please provide feedback. What did we do wrong? How can we correct it? We want your suggestions. We want your comments. We want your criticism so that, again, we can provide you with the best content ever. And with that being said, bye bye.